Our objective today is to be able to find the greatest common factor of two or more numbers. Common Core Standard 6NS4. Two vocabulary terms today. First, a common factor is a factor that two or more numbers share. For example, 18 and 30 have common factors of 1, 2, 3, and 6. 1, 2, 3, and 6 each divide 18 and 30 evenly with no remainder. A second vocabulary term is the greatest common factor, or GCF. The greatest factor shared by two or more numbers. When we look at the common factors of 18 and 30, 1, 2, 3, and 6, the greatest of those common factors would be the 6. There are two ways that we can find the greatest common factor. First is by listing the factors of the numbers that we're looking for. All right. First, if I list my factors of 24, 1, 2, 3, 4, 6, 8, 12, and 24 all divide 24 evenly with no remainder. My factors of 40 are 1, 2, 4, 5, 8, 10, 20, and 40. The greatest of those, your common factors are 1, 2, 4, and 8. Right? Because 1, 2, 4, and 8, 1, 2, 4, and 8 appear in both sets of numbers. The greatest of those common factors would be 8. So let's take a look at this example, and we'll let's see. We'll do 18 and 30, right, and find the greatest common factor of 18 and 30. First, we list our factors of 18. And when I list factors, I always like to start with factor pairs. So we have 1 times 18 is 18. We have 2 times 9 is 18. We have 3 times 6 is 18. All right. I list my factors of 18. We have 1, 2, 3, 6, 9, and 18. My factors of 30. If I list my factor pairs for 30, I have 1 times 30. I have 2 times 15 is 30. We have 3 times 10 is 30. And we have 5 times 6 is 30. I list those factors in order from least to greatest. I'd have 1, 2, 3, 5, 6, 10, 15, and 30. I look for my common factors. Common factors are 1, 2, 3, 6, and that's it. The greatest of those common factors then, right, would be the 6. So my GCF, greatest common factor, is going to be the 6. All right. Let's take a look at each one of these examples. And erase that. Take a look at each one of these and extend the page. Okay. We'll do each one of these at a time, one at a time. Start with example A. I have 6 and I have 21. My factors of 6 would be 1 times 6 is 6. We have 2 times 3 is 6. If I list my factors from least to greatest, I'd have 1, 2, 3, and 6. My factors of 21. Factor pairs, 1 times 21 is 21. 3 times 7 is 21. Are there any other factors of 21? I don't believe so. So I list them in order from least to greatest. 1, 3, 7, and 21. The greatest common factor, right, would be 3. All right, so your GCF is 3. Right. Letter B. We have 18. My factor pairs for 18. 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. So I list them in order from least to greatest. I have 1, 2, 3, 6, 9, and 18. My factors are 49. Start with my factor pairs. 1 times 49 is 49. And I believe we just have 7 times 7 is 49. From least to greatest, 1, 7, and 49. What is the greatest common factor of 18 and 49? Well, that's going to be the 1. Right? The 1 is the greatest and actually only common factor for 18 and 49. So your GCF here is going to be 1. Right? Then our last example, we have 14. Factor pairs for 14. I have 1 times 14 is 14, and we have 2 times 7 is 14. So I list in order from least to greatest. 1, 2, 7, and 14. My factor pairs for 28. We have what? 1 times 28. We have 2 times 14 is 28. And we have 4 times 7 is 28. I list from least to greatest. We have 1, 2, 4, 7, 14, and 28. The greatest common factor, the largest number that appears in both groups of numbers, would be 14. So my GCF, greatest common factor, is going to be 14. So if you're trying to find the greatest common factor by listing factors, always start with your factor pairs first, and then from your factor pairs you make a list of your factors from least to greatest. Look for your common factors and then identify the greatest of those common factors. All right, next page. We can also find the greatest common factor using the prime factorization of a number. We start by making factor trees, and then we write the prime factorization, and then from that prime factorization we can find the greatest common factor. Right? How's that going to work? Well, let's start with 18 and 27. I first start with a factor tree for 18 and a factor tree for 27 if I'm looking for the greatest common factor. 18, I'm going to use 3 times 6. 3 is prime. 6 is 2 times 3. Well, 2 and 3 are prime. Your prime factorization is going to be 2 times 3 times 3. For 27, we have 3 times 9 is 27. 3 is prime. 9 is 3 times 3. Each of them are prime. So we have 3 times 3 times 3. When we're identifying the greatest common factor from the prime factorization, I look for the factors that are common to both sets of numbers. And I have 3 times 3 and 3 times 3 here. So 3 to the second power is common. So your greatest common factor here, greatest common factor, is going to be equal to the factors that are common. So the 3 times 3, or 9. 9 is the greatest common factor for 18 and 27. So we'll do a couple more of those. Scroll down. And let's see, extend the page a bit. Okay, I want to find the factor, greatest common factor of 3 numbers here. So we have to first start by making a factor tree using the 3 numbers. So I start with 48. Factors of 48. Let's do 6 times 8. Neither is prime. 2 times 3. Both prime. 8 is 2 times 4. 2 is prime. Right? And 4 is 2 times 2. Right? And each of those are prime. We take our circled prime factors and we list them in order. So we have 1, 2, 3, 4 factors of 2. So that's 2 times 2 times 2 times 2. There are my 4 factors of 2. I have 1 factor of 3 for 48. Next we'll do 80. My factor tree for 80, I'm going to start with 8 times 10. Neither is prime. 8 is 2 times 4. 2 is prime. 4 is 2 times 2. Each of them are prime. 10 is 2 times 5. They're both prime. I have 1, 2, 3, 4 factors of 2 again. 2 times 2 times 2 times 2. Then we have times 5. And then finally I have 128. I'll write that over here. For 128, wow, what's 128? I see it's even, so I know that 128 is divisible by 2. 2 times, what would that be? 64, right? 2 times 64 is 128. 2's prime. 64 is 2 times 32. 2's prime. 32 is 2 times 16. 2's prime. 16 is 2 times 8. 2's prime. 8 is 2 times 4. 2's prime. 4 is 2 times 2. They're both prime. We have 1, 2, 3, 4, 5, 6, 7 factors of 2. Right, 7 factors of 2. So that's going to be, I'll write it over here, 2 times 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6, times 2. We look for the factors that are common to both sets of numbers, or all 3 sets of numbers. I have 2 to the 4th power here. I have 4 powers of 2 here. And of course here I can find 4 powers of 2 as well. So we have 2 to the 4th power is common to each of those sets of numbers. So my greatest common factor is going to be 2 to the 4th power, which is 2 times 2 is 4, times 2 is 8, times 2 is 16. Would be the greatest common factor of 48, 80, and 128. All right, let's do 36, 60, and 84. All right, I'll write that over here. 36, 60, and 84. All right, we want to start with our factor trees. For 36, I'll do 4 times 9. Neither is prime. 4 is 2 times 2. They're both prime. 9 is 3 times 3. They're both prime. Your prime factorization is going to be 2 times 2 times 3 times 3. For 60, we'll use 6 and 10. Neither is prime. For 6, we'll do 2 times 3. They're both prime. And for 10 is 2 times 5. They're both prime. Your prime factorization would be 2 times 2, 2 factors of 2, times 3, times 5. Finally, we have 84. I know that, what? 7 times 12 is 84. 7's prime. 12 is 3 times 4. 3 is prime. 4 is 2 times 2, right? They're both prime. When I write my prime factorization, we're going to have 2 times 2 times 3 times 7. I look for the factors that are common to each set of numbers. Let's see. I have 2 times 2 times 3 here. I have 2 times 2 times 3 here. I have 2 times 2 times 3 here. So to find the greatest common factor, we have to multiply. 2 times 2 times 3. 2 times 2 is 4. Times 3 is 12. 12 would be the greatest common factor of 36, 60, and 84. Right? We use our factor trees to find the prime factorization of the numbers. And from the prime factorization, we look for the factors that are common to each set of numbers. All right. So the on your own problems, if you take a look, all right, if I'm going to do find the greatest common factor by listing my factors, all right, why don't you guys try those problems on your own, and then you can come back and check your work. All right, but we'll do them quickly together. Number 1, if I want to find the greatest common factor by listing factors, I start with my factor pairs. 1 times 8 is 8. 2 times 4 is 8. So we have 1, 2, 4, and 8 are my factors of 8. My factors of 36, probably a bunch. 1 times 36. We have 2 times 18. I have 3 times 12. I have 4 times 9. And I have 6 times 6. A lot of factors of 36. If I list them in order from least to greatest, I have 1, 2, 3, 4, 6, 9, 12, 18, and 36. Well, what is the greatest common factor? The largest number that appears in both sets of numbers, right? I have a 4 here and a 4 here. So my GCF is going to be the 4. All right. And I'll just do one more, right, just so that we can see the difference here. So let's do 32 and 90, but we will use the prime factorization of 32 and 90. So let's start with a factor tree for 32. Right, this is problem 5. I'll do it down here. So we start with a factor tree for 32 and 90. So I'm going to put the 32 here, put the 90 here. For 32, sloppy 2. That's going to be 32 is 4 times 8. Neither is prime. 4 will write 2 times 2. They're both prime. 8 is 2 times 4. The 2 is prime. 4 is 2 times 2. The prime factorization, I have 5 powers of 2. 2 times 2 times 2 times 2 times 2. If we factor 90, we'll do 9 times 10. Neither one of those are prime, so I continue to factor. Factor 9 is 3 times 3. Factor 10 is 2 times 5. 2 is prime. 5 is prime. Your prime factorization here is going to be 2 times 3 times 3 times 5. We look for the factors that are common to each sets of numbers, right? And it looks like I just have a 2 here, and I have a 2 here, and that's it. Right? That's the only factor that is common to both set of numbers, so the greatest common factor of 32 and 90 is a 2. All right? We're going to stop right there with the lesson, right? You guys have seen the difference between finding the greatest common factor by listing your factors and finding the greatest common factors using your factor trees, right? I hope that will be helpful.